So today I'm talking to Bruce Devlin, who is widely known to readers of KITPLUS magazine through his regular column as Mr MXF, a leader in the development and the trailblazing of standards. And today we want to talk about codecs. So, hello, Bruce.
Hello, Dick. How are you?
I'm good. I'm good. So this is sort of Codecs 101 we'll start with. So what is a codec?
So codec, like all good things in the technology world, is basically a joining together of two other things. It's a coder and a decoder. So in other words, imagine that you had gone down to your local sweet shop and bought yourself a brand new 8K camera, because apparently they come with packets of sweets nowadays. And this thing's putting out gigabits per second of data, and you want to try and squeeze it through your mobile phone to get it to somewhere. Obviously, you're not going to get your 8 gigabits of data through there, so you need a compressor. So you want to try and throw away probably 999,999 parts per million, leaving 1 part per million that's left, which is just the essential goodness of that bit of video. Then you send that down the pipe. And then at the other end, you do your decode, and you take that 1 part per million and you sprinkle some magic on top of it. And suddenly the other 999,999 parts bloom into life, and the average viewer cannot see the difference. But we should not forget about the audio, because by the time you've done that with your video, actually the audio becomes quite a meaty, hefty kind of thing at the moment. So you then look around your audio field and you see, oh, I've got 70 microphones sprinkled around my capture. What I've now got to do is take my audio sound bed, squish that down, and select the sound fields that I want into my objects and sprinkle those across my tiny channel as well and reconstitute those at the back end. And suddenly, before you know it, you're sitting in a Dolby Atmos theater with some sort of special HDR, and it's all wonderful and all running off a mobile phone. That would be the dream. That's what compression is.
Yeah, okay. So we've got a couple of points there, which I think are important just to reinforce. First, when we talk about compressing video, what we're doing is throwing away detail. We hope we're only throwing away the details we can't see.
Correct. And I hope you're also not introducing stuff that wasn't there that you can see, those nasty artifacts which we all know and love and try to hide.
And the other important point is that codec is a bit of a vague word, because it can be the maths that create it, or it can be the device itself.
Correct.
Yeah.
And just like most things in our industry, we overload and reuse the words and generally seed as much confusion to make it look like industrial magic as much as we possibly can. Other post facilities are also available.
So again, just to set the ground rules, let's make the difference between a codec and a wrapper and a transport stream.
So the compressor or decompressor or codec, that tends to be just the element that does the squishing and unsquishing. And so words here would be words like Mpeg, words like Prores, words like AVC, HEVC, ultra something or other, super this, wonder that. They tend to be the words about just getting rid of the stuff. But the stuff itself needs to be wrapped in order to synchronize audio and video and subtitles and all sorts of other things. And those wrappers could be things like an MXF file, or a QUICKTIME wrapper, or a Matryoshka wrapper, or one of the other 1,000 different file formats that are out there. But more so, a lot of these wrappers kind of are at-rest wrappers. You might want to then add an extra layer of wrapper to try and transmit them in real time. So you might end up with a wrapper that we might call ST2110, or NDI, or UDP, or RTP, or another sort of wrapper around the first wrapper to get it from A to B. Transport Stream was one of these early such wrappers that was able to take a compressed video stream, a compressed audio stream, a compressed subtitle or data stream and smunch them all together and stick them over a satellite or over a cable or over a terrestrial broadcast. And that's really what broadcast has been since about the early to mid 90s.
Great. Okay. So are there different sorts of codec? Is there not one grand codec to rule the world?
There have been so many companies that have brought out their grand codec to rule the world. And when you scratch the surface, pretty much you discover that there are different business requirements for a codec. So when we're delivering to the consumer, which is where most people are familiar with their codec, you're trying to get rid of as much data rate as possible. Pretty much you're squishing down to the extent where the picture is just good enough for the consumer, and then you back off a little bit. In fact, specifically in my early days of compression, I was building hardware compressors, and we were asked to build a compression analyzer that was connected to the GPI on the switchboard. So when the switchboard started to get lots of complaints about the compression, we backed off the compression a little bit. Absolute true story. We never quite built it, but we built something that was almost the same. And actually it turned out to be a very successful product because we were just hovering at that level of acceptability, which was where the level of profitability for that particular customer back in the early 2000s was. So when you're in the B2C world, the business to consumer world, you've typically got a small number of source streams and a very large number of output streams. And you're constrained by the bandwidth to the end consumer, particularly in the UK. Although other countries are available, so I've been told, especially by people in Japan who have a lot more bandwidth. So you're trying to squish down that bandwidth to get the best experience for the consumer. So you might be taking something that started off as gigabits per second and getting down to megabits or even kilobits per second. I mean, a standard definition stream that goes over a satellite nowadays might be down in the hundreds of kilobits per stream, down from where it used to be back in the early days of broadcasting, where you'd be up at 6 or 8 megabits for standard definition. We're down into hundreds of kilobits now. And 6 megabits, actually, that's quite a high quality HD stream nowadays. So you can see that in the B2C world, we're really getting to the point where the HD bandwidths of today are what the SD bandwidths of yesterday were.
And that's significant because broadcasters are renting bandwidth by the megabit a second.
Absolutely. There is a fixed amount of bandwidth available, as anybody who's tried to buy a fiber feed to their home is aware that the more bandwidth you get, the more you pay, and that's true for everyone.
Okay.
However, if we sort of go upstream from the B2C world, we've got this quite complicated business-to-business world. We've got content aggregators who pull together lots of stuff and then give it to somebody else who then gives it to the consumer. Now, in that business-to-business world, you can't really operate at the consumer bandwidths. Because if you're down in the, say, 8 or 9 megabits for an HD feed, and you do something to the stream, you have to then recompress it. And if you then re-encode it at 8 megabits per second, the quality is, what's the word? Pants. The quality is absolute pants. It's really horrible. So in this B2B world where you're making versions and you're aggregating content and you're inserting ads and you're doing all sorts of stuff, you tend to work at a higher bit rate that we call a mezzanine bit rate. And for HD, depending on where you are, that could be anything from, 25 to 50 megabits if you're in a quite heavily compressed bulk content world. That might be something like a newsroom. Or if you're right up at the top end, where you're talking about, original Hollywood movies being mastered for different territories, you might be up at 400 megabits per second, where it's only, only just compressed for a 4K original, or 120 megabits for an HD original. So the bandwidths in this middle bit, where you're kind of refining the content for a territory, or you're doing some processing to conform and get rid of nudity or swear words, or you're inserting new storefronts in the local script language of the country in which you're delivering that movie to. All of that stuff that you do to maximize the revenue for your content, you do that at a much, much higher bit rate. And again, this is so that the cascade effects of the downstream B2C codec aren't visible, and you still end up with a quality product by the time the end consumer's spending whatever it is on their movie or their sports stream.
And the significance of that technically is that mezzanine codecs tend to be peer-to-peer services, so you can afford a good quality device on each end of the line, whereas the final delivery stage, I mean, traditionally would be one encoder at the broadcaster and however many million set-top boxes there are watching it, and those set-top boxes would like to spend no more than $1 on the chip that's going to decode the stream.
Absolutely. It's all about volume when you get to the consumer, and it's all about maintaining that quality to the limit that your business can afford up in the mezzanine. And one thing that's important, especially to people watching this who sit in front of, I don't know, Adobe or Avid or Final Cut, is that each time you do something in that editor, you're effectively making a new version of those scenes. You're making a new version of that movie or that advert or that sports cut or that highlights reel. And so you're re-encoding a new bit of material. So when you're working in an editing environment, you tend to be working at the mezzanine level, unless you've got really fat pipes and you can deal with uncompressed. And so if you look at one codec that people are quite familiar with at the mezzanine level is the Prores Codec. And people often get confused about, well, what's the difference between ProRes 444 and XQ and LT and XYZ and what is all this stuff? And it really is all about measuring what's the level of quality that your business has to operate, such that by the time it goes into the more of getting it to the consumer and it gets transcoded 11 times before it actually hits the eyeballs, how do you preserve the quality that you think you had, such that the end consumer gets at least a representation of that quality to justify the fees that they're paying for the content that you've made?
So Moore's law and computers getting ever more powerful, has that changed the dynamics of compression? Does that mean that we can live with higher bandwidths, or alternatively, we could compress more without eyeballs being scarred?
It's absolutely both of those. It's absolutely the case that Moore's law has had a massive, massive difference. And it's not just Moore's law for computing, because the original Moore's law was for computing. It's also Moore's law for storage, and it's also Moore's law for network bandwidths. What I find really interesting is, I've been involved in compression and wrappers and business efficiency pretty much since the day I joined the BBC about 11:21, I think it was. It seems like a long time ago. And I've never yet met a business owner who, when faced with the choice of giving the end consumer quality that they can't see because their TVs won't show it, or keeping the profits for themselves, I've never found a business owner who found that to be a difficult decision to make. And so pretty much the way that a lot of businesses have been running is to give the consumer the quality that their AV system in their environment can handle, maybe a little bit more to differentiate themselves against their competitors, but not 2 orders of magnitude more. Because once you've given them 2 orders of magnitude more, that's cost you an awful lot more money. You've increased your cost base without actually being able to reap the rewards of having a bigger subscriber base. Because at the end of the day, it's still entertainment. And if it's often the catalog that is the biggest thing that people will buy if you're a consumer. And a good catalog, well presented, is kind of, that's the thing that everybody's trying to get hold of in order to get all of those consumers. And although compression is really important, it's not as important as having a good catalog in the first place. And so that's where these business trade-offs start to come in.
Yeah, certainly no consumers go out to buy compression.
Yes.
They go out to buy content, obviously. Yeah. So what's the latest? What's the current good things in compression? So
it's interesting that people might have read various articles on the web about, Mpeg's dead. Even Leonardo Ciaglione, the godfather of Mpeg, says that Mpeg's dead. And I get a lot of email in my inbox about that. And it's an interesting observation. And I think it's not that Mpeg's dead. It's that we're at a very interesting intersection of where the disruption in business and the disruption in technology have reached like a perfect storm. And I say that because up until relatively recently, a lot of the really big bulk transcoders that have been delivering to consumers, the easiest way to do that has been buying a bit of hardware that you physically plumb into an uplink to a satellite or a head end for a cable station, or you put it really close to an origin server for doing OTT, and you get the best bang for the buck by putting as much content through that thing as you possibly can. But cloud computing and fat pipes between the clouds has really quite changed the economics of that. And the reason why that's interesting is because it allows different compression techniques to suddenly become available. If you can suddenly scale a bit more computing for a difficult scene, suddenly you don't have to commit your ASIC to be the right sized ASIC just for an HD bit of picture or for a 4K bit of picture. You can suddenly start to vary your computing and vary your calculation depending on the value of your content and the sort of material that you're putting together. So this has changed the economics of compression. And I think this is very fascinating because we're seeing different compressions being traded off in different places. So by and large, we've already talked about two areas of compression. One is the B2C, business to consumer. Another is the B2B, the sort of the mezzanine level. But there's also what I call origination compression. Anybody who shot 4K on their mobile phone, and I just have to say that out loud again, 4K on your mobile phone. So better compression is available, or better resolution is available in your pocket than on the feeds that you get from the professionals. Just crazy, crazy times we're in. In order for that to be stored, whether it's on your phone or whether it's an ARRI or whether it's a Blackmagic or whether it's a Sony or a Panasonic, the raw format that goes into the memory card or the whatever, those tend to be compressed, but they tend to be losslessly compressed so that you can mathematically recreate exactly the number of photons that landed in each of the photo sites in the Bayer mask. So those compressions tend to be very useful for getting stuff on and off the camera. And the reason you want it is because you want to get stuff on and off the camera quickly. Yay, on and off the camera quickly. However, because we live in this weird world where we've got high dynamic range and wide color gamut at origination, but not necessarily at the consumer, we're then left in the middle with this interesting choice of, well, do I shoot in HDR but master my content in Rec 709 for TV because that's where the money is? Or do I do it in high dynamic range for OTT because that's where all my new customers that I'm about to sign up are going to be, maybe? So there's all these really interesting business decisions being created, of which there's no clear answer. But the technology is driving that possibility. And I find that very interesting, that the compression is allowing these business decisions to be made, but not giving us the answers.
Yes. But it is nice that it is back to being a business decision. Interesting. You're talking about the cloud.
Yeah.
Because compression is hard.
It is hard.
And it's not conventionally computationally hard. It's parallel processing hard.
Yeah.
So it's not like putting an airline reservation service in the cloud, which is very simple in comparison. So you're looking at GPUs to do all this heavy lifting.
Yes and no. So it's interesting that as cloud processing and as the sort of the parallel computing world becomes more mature, I'm trying to choose my words carefully without naming brand names, we're particularly seeing new sorts of codec, particularly in the mezzanine world, come to the fore. So in my role as standards vice president at SMPTE, we do quite a few mezzanine type codecs within SMPTE. And most of these have traditionally been what we call transform codecs. So just a bit of techno geek here to explain what those are. So many people watching this will have heard of the DCT, the discrete cosine transform. And if they think back to their university courses, they might remember the fast Fourier transform as a way of converting stuff from the spatial domain into the frequency domain. Well, the DCT is like half a Fourier transform. It's like you throw away the sine bit and just keep the cosine bit. There are other transforms. Wavelet is one of them. Wavelet you can think of as like a more efficient transform for visual type arts. But essentially, a lot of these transform codecs work the same way, in that you do the transform on the picture. You discover, because most pictures have a lot of DC in them, because there's a certain average number of photons coming at you and you have to code that. And as you look at higher and higher frequencies, there's less and less information, except if you're a splendidly bearded gentleman like yourself, Dick, in which case you've got lots of high frequency just where the eyes are concentrated. So beards are really hard to code. So thank you for testing the compression systems globally. I admire your diligence. So the more high frequencies, the less information is, the less there is to send. So this is why transform coding has been particularly popular. And it's also been relatively straightforward once we cracked it back in the early 90s about how you do that using ASICs and CPUs and GPUs to basically build these long pipelines. But there are other compression techniques. People might have heard of a thing called quad tree coding or fractal coding, or it goes by different sorts of names. Mm-hmm. And SMPTE's quite proud that we've just recently standardized one of those called VC6, which basically works on having a hierarchy of different resolutions. And within each one of these different resolutions, you kind of say, well, this bit of picture looks a bit like that bit of picture. And if we can just say, because this bit looks like that bit, we don't have to send it. And at the end of the day, this is all compression is. How much information can I not send, yet still replicate the picture? And by looking for these similarities between the different resolutions as you go higher and higher resolution, but also within the resolutions, and scaling the picture in different ways to try and minimize what you have to send, you can, by having a compression algorithm that's quite complicated and very, very, well, for want of a better word, bitty, you can actually end up with something that's really easy to parallelize, very, very hierarchical, so you can change resolutions. But actually, when it comes down to it, it's really quite CPU friendly. You're not really doing anything that's super GPU necessary, but actually, if you do put it on a GPU, it really does go fast. So we're starting to see some of these new compression techniques come out either as standalone things like VC6, or in some of the inner layers within other coding loops. And you see some of these techniques being used inside some of the new encoders like VVC coming out of the Mpeg group, or LCEVC also coming out of Mpeg. We're seeing these new layers, these new ways of enhancing higher detailed layers, so that the base layers that you send, where you've got the most eyeballs, might be effectively high definition resolution on low bandwidth links. And then with each subsequent layer that you decode, you get a little bit more stuff. So if you're on a better bandwidth link, you might have high definition that really looks more high definition. And the next layer up might give you high dynamic range. Then the next layer above that might give you 8K. And the next layer above that gives you, well, pretty much as much resolution as you got from the thing that was being sent. So we're in this really interesting world where, because there's variable bandwidths to the consumer all the way around the planet, and because we've got these variable links at the Metzning level, and because we've got these super cheap cloudy computing things, basically what used to be a very structured, two-tier compression world has suddenly exploded into a whole bunch of almost proprietary, almost private links.
Yeah, and I suppose that brings us to the last point. You mentioned Leonardo Cariglione earlier.
It's easy for you to say.
Not at all. The Godfather of Mpeg, and anyone who's met him will know he's quite a forthright character.
Yes, he's not a shy, retiring wallflower by any means.
He certainly isn't, and he's recently posted on his own blog about the end of Mpeg and how this is possibly the end of all order and management in the codec world. So if Mpeg as an organization is ceasing to exist or ceasing to have influence, who does look after us? Who does keep us standardized and keep us working in the same direction?
Well, let me answer that first with a similar but slightly different question, which is a personal existential crisis I have. Do we even need standards in the media world anymore? Why don't we just do everything open source? And I get asked this over and over and over again. And I personally believe that we do need standards. I wouldn't be putting a lot of effort into trying to help modernize SMPTE and become a more welcoming place if I didn't think that we needed standards. But I also think we need open source, and I think we need a good, healthy mix of these two communities. And anybody who's working in open source at the moment knows that it's far from a loving garden of friendly people always getting on. You know, it's not a nirvana by any means. And in some ways, the standards organizations and the standards community, whether it's ISO or whether it's SMPTE or whether it's Senelec or whether it's ARIBE, we get together because we need to have some agreement at scale about the way that we can distribute content. Now, whether that's let's choose a common codec, or whether it's let's have a common wrapper, or whether it's having a common transport, at some stage to get the scale that we need, we have to agree on a common way of doing stuff. And to a large extent, standards organizations exist to explore those disagreements and to put in place really quite strict rules about how people who fundamentally disagree and are quite likely to have a discussion by pointing at the screen and shouting loudly, been the recipient of those over the years, how we can have that discussion and let people vent, to be perfectly honest, yet still come to a compromise solution that allows us to achieve the scale that we need for the business to move forwards. And by business, I mean distributing movies, distributing sport, having good interactive conversations. But that's not to say we can't have really big and important open source projects as well, really going for it gung-ho and blazing a trail when that's the right thing to do. And I think that is also a healthy way of doing stuff. And in the middle, there's this kind of mushy area where it's not certain whether it should be a standard or whether it should be a big open source project or group of projects. And I think compression is currently sitting at that mushy area between the two. The business models that depend on compression are really being disruptive at the moment, really disrupted. Who knows whether or not broadcasting as we know it will survive for the next 10 years, or whether the sort of the OTT Netflixy model is going to survive. Will Amazon, who's been putting all of this live sports out, really start to dominate live sports with live sports in the cloud? Or will the more traditional Olympics, Wimbledon, Super Bowl kind of broadcasting, will that out? I don't know. I just build the stuff. And it's because compression is vital to these domains, and because the business is being disrupted and the technology can be implemented in the cloud, in an ASIC. You know, on this phone here, I can do 4K. Because we're in this area of disruption, nobody really knows. What I do know is that as the head of a standards organization, okay, not as big as ISO, but still SMPTE's got a bit of clout in the media industry. I know that if SMPTE doesn't change the way that it does standards, it's going to be not relevant in the very near future. And I've been putting a lot of personal effort in to try and make us, SMPTE, more receptive to open source projects, more receptive to doing things with microservices rather than bits of hardware, trying to make certain that we can register just the bits of data we need to exchange 2 bits of content. So all of this stuff needs to happen in the standards organizations if we're going to be relevant. Because if we're not relevant, you know what? Smart people out there will do it a different way.
Bruce, wonderful to talk to you as always. Thank you very much indeed.
My pleasure.
Bruce Devlin.
Thank you very much.